everyone. So today we're talking about Newton's formula, okay? And so these notes are in your packet, and I just want to give you a quick overview here because I'm going to have to split this into, a couple different videos. So this first video, this one that you're watching right now, is going to cover this first page of your notes, all right? And this is just an introduction to the formula itself, couple of examples that kind of go along with that, but really just a real basic introduction, okay? And then you should also have this page that has some examples on it. So I'm going to do these examples in a separate video because these ones are very dependent on your graphing calculator. Okay, so just as a heads up, when you go to watch that video, you're going to want to make sure you have a calculator in front of you, and you're going to want to make sure you're doing the steps right along with me. Okay, because just watching me do it isn't going to make you be able to do it later on. Okay, so that'll be a separate video, examples 3 and 4. And then I'm not sure if I left this page in your notes or not. If I did leave this in your notes, we are going to do this table together in class, probably when I see you on Monday. Okay, so if you have this in your notes, don't worry about that for today. Okay, so we're going to get started here and talk about what Newton's formula actually does. Newton's formula is it's a law of physics, really, and it was designed to measure the height of an object in the air as a function of time, meaning you're looking at, after this much time, how high will this object be up in the air, okay? And so really big things to know here is that this formula compares height with time, and this will work for anything that's just like dropped or something that's launched in some way. If you throw something or shoot it off a roof or something like that. Okay, so the formula itself, it's this big scary thing, and I realize that looks kind of terrifying. Okay, we're going to talk through it. I promise once we do it a couple of times, you'll see that it's not as bad as it looks. But again, keep in mind the formula was designed to let you plug in the time and find the height. Okay, this is meant to give you height based on the amount of time. So this H here represents height, and the T, which shows up here and here, represents your time, okay? And so those are like your X and your Y. Those are going to stay variables. We're not putting any numbers in there, okay? The places where you are going to put numbers are the G, the V sub 0, and the H sub 0, okay? So starting with the G, this one's kind of a weird one. This is really meant to measure the force of gravity, okay? And specifically, it's the amount of force that gravity is applying to whatever object is falling or being thrown or whatever, okay? So the good news is gravity is the same all over planet Earth. As long as you're on planet Earth, the force of gravity is going to be the same. Okay, that means we're always putting in the same number for G. We almost could get away with just plugging a number in there and leaving it there. The place we run into problems is the difference in measurement systems. If we're measuring in feet, we're going to use 32 to represent G. And if we're measuring in meters, we're going to use 9.8 to measure G. Okay, so you do need to know those two values. The only difference there is one is being measured in feet and one is being measured in meters. And I believe the measurement is like feet per second squared or meters per second squared, but I actually don't even write the units because I find that it confuses people when they go to put it in the problem. As long as you know this, you're good to go. Okay, so for every one of these problems you do, you're going to have to pick between these two numbers. These other two will actually show up in the problem itself for you. Okay. And I want to point out that anytime you see that subscript of 0, anytime you see the little zeros down there, that represents the initial amount of something, okay? So when you see V sub 0, that's talking about initial velocity. Velocity is very similar to speed. There are some differences. Velocity, the big difference is velocity can have a direction, speed cannot. We'll get far more into that when you take physics, but for right now, just know that you're looking for velocity or speed to go right there. And then H sub 0 is initial height. So are you starting from a height of 20 meters up in the air, something like that? Okay. So when we go to write this formula, all we're really doing is plugging in numbers to these three values and then leaving this equation alone, okay? That being said, I think I'm actually going to jump down and do example 2 real quick. And I actually might try to zoom out so that you can see the formula too. So let's start by getting rid of my face here. And then, whoa. That's not what I wanted to do. There we go. So now you can see example 2 and the formula at the same time. Okay, so notice in example 2, it says Alice threw her graduation hat, that should be hat, into the air from a height of 4 feet. So that height of 4 feet, that's your initial height. That's the height you're starting at. So that's going to be my h sub 0. And at a speed of 24 feet per second. Remember I said that for our purposes, speed and velocity can be kind of the same thing. So we're going to just call this my initial velocity, okay? And I should also point out that both of these are being measured in feet, so that means our g value is going to be 32 from up above, okay? So when I go to write my equation, I'm starting with h. H equals negative 1/2 g, which we said is 32, t squared, so my t is like my x, that's just going to stay the same, okay, plus my initial velocity, which is 24, t, because that t stays the same, and then plus my initial height of 4. That's really all there is to this, okay? That's all it means when it says to write the equation. That's all you have to be able to do, okay? There is one more thing we could go ahead and simplify a little bit here, and that's just this right here. You could go ahead and do negative 1/2 times 32 and make it a negative 16, and so your equation looks like this. Negative 16t squared plus 24t plus 4, and that's it, okay? If the question just says to write the equation, that's all you have to be able to do, okay, is set up the equation that way. Okay, so if you think about what the graph of this thing would look like, we know it's going to be a parabola, okay, and we know it's going to be upside down because that's negative, sort of like this picture you see right here, okay? So all of these graphs are going to have some semblance of this. It's going to look similar to that. So let's just practice reading some things off the graph, because that is going to be one thing that you want to be able to do. Notice this one doesn't use an equation at all. This one is just asking you to look at the graph and answer some questions, okay? So for example, the maximum height, this point right here represents the maximum, okay? And so if we're reading height, we would read straight across. Gosh, it's just below 125, I think. So I don't know, maybe about 120. This is an estimation, okay? As long as you know to read it from this side, and honestly, even if you said that was exactly 125, that'd be okay with me. But then notice it says, how much time did it take to get there? Notice that this one was asking about height, so I read it from this axis. This one's asking about time, so I'm reading it from this axis. And so time-wise, if I go straight down here, looks like it's right about 5 seconds. Okay? Total time the object was in the air. So it starts at 0, it goes up, it comes back down. At 10 seconds, that's how long that's when it's back on the ground again. So I would say it was in the air for about 10 seconds. Okay? The initial height of the object, this one's kind of a bad example. So the initial height, here's height, right? Initial would be at the beginning, and this one looks like it was starting right on the ground. It's starting right at 0. So the initial height is just 0 meters, and actually I realize this now. This is measured in meters, not feet, so this should be 120 meters up here. Whoops. But sometimes you'll see these parabolas that start like up here and then they make their arch, okay? So then you would say your initial height would be like 25 or wherever it happened to start, okay? And then the height of the object after 7 seconds, this is like my t value, right? So I'm going here to 7 seconds. I'm going to just read up to the graph and read straight across. Oh, I kind of went down there. I don't know. What do you want to call that? 80, 85, something like that. 85 meters. Okay, just an estimation off the graph. I can see my line slant downward here, so I don't know, maybe 85 or so. Okay, so those are just estimations off the graph there. Even even this line, kind of diagonal. Probably closer to 100, quite honestly. Yep, I would say probably closer to 100. Sorry about that. But yeah, that's all there really is to this. So just real quick, in your homework packet, you actually have 2 pages of homework on Newton's formula. This is after your quiz review. You have this page that says Intro to Newton's Formula, and then you have another page that says Newton's Formula Homework. Based on what we did in this video, you would be ready to do this first page. So now that you've done this video, if you want to go back and do just this first page, that would be perfectly fine. And then you can watch the second video and do the second page, okay? So good luck with that, and again, stay tuned for some graphing calculator tutorial.